All right, we are going to move away from fixed pitch propellers and now start talk about adjustable propellers. But the good news about this is we've already covered all the theory of propellers, and nothing's going to change. It's really just about now more from a maintenance perspective or from an operational perspective, how these propellers actually work and what you're going to be doing with them. And of course, as I start this picture right here, we have, I wouldn't say I have a favorite airplane, but I sure do talk a lot about Stearmans. And I've built a lot of these Stearmans. I've worked on a lot of them. And so I guess I do enjoy them. This particular Stearman, and they came with different engines on them. This particular Stearman has the 300 horsepower R680, Lycoming R680. And I know that, and I shouldn't, but because Lycoming R680 that came in the 300 horse version, for some strange reason, put the exhaust on the front. And I think that's ugly. And I don't like that version because I don't like the ugliness of it. But other than that, we could just take a look, stop and take a look at this particular photo, even though when I zoom in, it gets a little blurry and maybe that was a bad idea, but you know, things to talk about that we've already covered that might be interesting to you, or it might not. I don't know, I'll let you decide. One of the things is this is the particular hub that went on a spline shaft that I talked so much about with the, maybe it's better zoomed out a little bit, with the cones in it. And you can see back here the thrust nut, and the thrust nut actually has little cutouts in it, and that's how it works. A spanner wrench goes on there. So there, I can see the thrust nut back there, which there's a cone sitting on against that thrust nut, and then there's and then the hub is sitting against the cone, and then there's a cone up here in this little area right here that is sandwiched. It's two halves, and this kind of sandwiches in there, and it goes on there. And then these two giant holes here are for the bar that goes through where you tighten it down. And then these little holes are where the safety goes through. And the safety goes from the inside to the out. In case the cotter pin were to come off, then it would stay put. Other interesting things. This big old stripe right here is because this is a ground adjustable propeller. And if you loosen up this clamp and you loosen up that clamp, you can actually rotate the propeller in the hub and reset the pitch of the blades. But one of the things you don't want to happen is the pitch of the blade to change or slip. So this is a slippage mark. And if that tape isn't perfectly aligned, then the pilot would know that the blade is starting to slip, which would cause a lot of vibration because one blade would have more or less, actually, it would have less of a bite because if it's slipping, its centrifugal force is going to move it towards a lower blade angle. And that's how it's going to do it. Anybody tell me what this handle is right here?
Is it a dipstick?
What handle?
Ooh, I like dipstick. Dipstick is good. That's the primer.
Oh my gosh, I was trying to say.
Yeah, that's the primer. Sometimes I think it's the primer on this one, and there's one inside too. And the reason why they put the primer out there is I'm thinking about it. I'm like, why would they put the primer out there? Well, because a lot of these planes didn't have starters. And it would really suck to have to walk all the way around the plane, climb up on the wing, reach inside, do the primer. And these primers are long. They come out almost like 8 to 10 inches. It's crazy. And then walk back around and do it. So they put the primer here because you're going to hand start it. Some planes, rather than the primer, this could be actually, I could be wrong on it. And this could be this next thing. And this is the starter system. And they have inertia starters on it. And so the way it would work, and I've seen it done on videos and stuff, and I cringe when I watch it as an aircraft mechanic. Like, oh, don't do that. You put a handle in there and you crank the handle and you hear the starter wind up, and it's like an old fashioned siren. It's really hard. You get it going, you get that starter wound up, and man, it's just going like crazy. And then you grab this knob and you pull it out, and it engages the starter into the gear teeth of the back of the engine. So basically what you have is a starter running at, I don't know how many hundreds of RPMs, and the engine going 0 RPM, and you pull this out and the two slam together, and it just, oh, it's horrible on the gear train, and bam, and then it starts to go. And this old timer that I worked with, he was a pretty cool dude about this stuff. He says, you know, if you think about it, he goes, this is a better way to do it. He said, just pull and engage it and then start winding it up. And yeah, sure, the prop moves real slow at first, but you get the whole thing going anyway. And then once it's going fast enough, you tell the person in the cockpit to hit the magneto switch. And that's the way we always started them that way, because it was so much kinder to the engine. And I don't know, while we're playing Trivial Pursuit, what is this bump right here? I'm just going to drink my scotch.
Is that the fuel gauge?
The wings.
Fuel gauge. I think that's the sump. Fuel gauge is actually right in the middle. It's a sight glass that hangs down. You can't see it. Am I going to have to tell you what that is? That is a mirror, so that the person in the back can see the person in the front. So when you look in the mirror, you see each other's faces. Because this was a World War II trainer.
I was going to say that, but I felt like it was going to be a stupid answer.
No, it's the mirror. So I don't know. Again, just playing a little Trivial Pursuit with you, because it means that I don't have to write anything for a few minutes, I guess. All right.
What aircraft is this?
This is a Stearman. And if I was really a cool kind of a guy, I could tell you exactly what it is. Like it's a PT-17 or a PT-13 or a PT whatever. I'm terrible at that. And the reason why is because the PT number changed depending on the engine of it. So I just don't remember what it is. It is missing the oil cap right there. I guess I could ask you what this is.
Pitot tube.
Matches this right here. That's where you stand, because the gas tank is up here. So you climb up here, there's wing walk up here, and then you stand up here so you can reach the top of the fuel tank when you fuel it. So, all right, talking about props, ground adjustable prop. Okay, so let's see, I've got some stuff there in my reading. This has been back in the day before I put everything in Canvas. So I'll tell you what to go do. So we're going to talk about ground adjustable props. Let's see, here we go. Ground adjustable props. Ground. And while I'm thinking about it, because I should be thinking about this instead, since we just finished this last segment, that would be what, our module 5. That means that I need to put a module 5 test together, but I'm not going to do it tonight. And I know tomorrow I have a pretty busy day. And so therefore I will get it done probably tomorrow or Sunday, which means I will give you all the way through the week into next weekend to do the test. But by then I'll have finished this one. So there'll be probably 2 for next weekend. Everybody good with that? I don't see anybody.
Very good with that.
Yep.
Okay.
Yes.
Give me a thumbs down if you're not. And then I'll stay up late and get it done tonight. So it's due on Monday if you like. All right, so designed so that a mechanic can adjust the blade angles, to give a desired performance, within reason. I see guys like Harry come into the shop saying, hey, you said desired performance. I would like to go supersonic, please. What blade angle will I need for that? So I'm only making fun of Harry because he owns a plane. Low blade angle, for climb or short takeoff, short takeoff.
Why is that again?
Okay, so remember, if I go to a low blade angle and I do a static run up, I'm going to get the highest RPM out of the propeller, as opposed to putting a low blade angle on it, high blade angle, and then it's going to be more of a cruise speed. So I guess if we're going to think about it in cars, this is like low blade angles like first gear. Like you had a 3-speed transmission. So this would be like first gear. And then cruise would be like third gear, and then second gear would be your all around. So I'm maybe talking to the wrong generation.
Nope, that makes sense. That's perfect.
Okay. For guys like me, makes sense, you know. A long time ago, I actually drove a tow truck, and the tow truck had it was technically a 4-speed. It had low, first, second, third.
Granny low.
And so you would normally take off in first, which is really second, but you could never take off. I don't know. Never mind that. I'm just going to keep that. Okay. So high blade angle, high date blade for top cruise speed, So most people in their aircraft, for just standard whatever you want, like we had a lot of customers with Stearmans, but we had one that kept it over at Executive Airport, and you know, it's a fairly long runway. There's no real need to climb rapidly, so you have plenty of takeoff room. And they wanted just a good all-around kind of propeller. So they would opt for your second gear, using my analogy, which I didn't write down. So it's in the middle between low blade angle and the allowable high blade angle. But I know we had one customer who is doing it was called a freedom flight or some flight, where it was celebrating something, and I don't remember anymore. And what they were going to do there in this huge flight, and they were going to fly from here all the way to New York and make this flight around the Statue of Liberty. So they had to get from here to New York, and they wanted to go as fast as they could because they're in an open cockpit biplane, and they're already slow to begin with. And so I remember they brought in their aircraft, and we set it to the highest possible blade angle we could give them. And then when they got back, we switched it back to their medium blade angle. So like for my airplane with my fixed pitch, I can do that once or twice or up to 3 or 4 times, maybe through the life of the prop, before I have to throw it away, using a giant hydraulic press and a guy who knows what he's doing. With this one, it's infinite. You can change it every day if you wanted to. You got the money to do it. So these are typically used on older aircraft. I'm not really familiar with any modern aircraft that uses something like this, except that maybe some of the home builts are using a variation of this. Like I said, I think the Ivo prop might be a variation of this, the composite one. Design. We'll talk about the design of this. So the design, it has a 2-piece hub design, two-piece hub design I'm going to actually show you the picture, and I'll tell you what it is, and then we'll come back and I'll write it. So 2-piece hub design. So this hub has a split that you can't see right on the very top and right on the very bottom. And so you have the back half and the front half. And that allows you to separate it out and stick the hubs in, because the hubs have a gigantic bulb on the end of the butt end, actually is what it's called, that's going to fit down in here, so that all of the centrifugal stresses are designed right around here. So you have the back half and the front half. They are a matched pair for life. I believe they're made and then cut in half, so you have to save them, keep them together, I mean. And then it's got the clamps that go on it. And so the clamps, when the clamps are loose, you can put what's called a blade paddle, which is just a giant tool that has a cutout where the blade sits in it. And you can rotate the blades circular and adjust your pitch, your blade angle with them, I should say, blade angle with them. And so we got, what else we can say? We have the clamp rings. Here we got the clamp rings. Sometimes the blades can be wood or steel. This is the prop that uses the steel blades, and it's the only prop I know about that uses steel blades. And those steel blades are actually hollow. And remember when we looked, last week, which was actually an hour ago, that we're looking at, you couldn't do any repairs to steel blades at all. One of the reasons why is because they're hollow, to keep the weight down, because they're steel. But they do have a problem with corrosion inside, so they get shot peened. So
what's inside the hub? Nothing?
The prop at this point. So otherwise nothing. Just what the end of the prop goes in here, and the end of the prop goes in this way. And then coming from behind, this is going to be the prop shaft, the shaft of the crankshaft.
Kevin.
Yeah.
And you can only move it with the tool?
No, when these are loose, if they're loose enough, you don't need a tool at all. They'll rotate quite nicely.
Oh, okay.
It's just the tool is helpful because then you don't have to loosen this quite as much. The problem is when you loosen these up, the blades actually sag. And so the magic of my awesome drawings, we have the hub and then the blades, they actually sag. I'm being exaggeratory, but they sag down, not quite as bad. And then imagine trying to set the blade angle on something that's sagging. And then when you tighten up the blades, they straighten back up, and then then that changes your angle a little bit. And you're talking about angles, you're trying to get within 1/4 of a degree or better. I try to get dead nuts accurate. When we look at this prop protractor, they have veneer scales on them. That's how accurate they are. So you can read to 1/10 of a degree. So you're trying to get perfect. So by barely loosening it, just loosening enough so they're still really tight, but you need a big paddle to turn them, it takes you less time to accurately adjust them.
Why not adjust it when the propeller is up and down?
Because then it's really difficult to use a prop protractor because you're talking about an angle. If you think about angles and how they work, I can't draw an angle for you. That would make sense. But when it's horizontal, you're actually, if you're looking at the side, then you're kind of looking at a true angle. But if it's straight up and down, then it's not really an angle that's measurable. I mean, how would you figure out a zero reference plane? Think about if you were trying to build a house and you had a 2x4 in the wall that was going up and down. What good would it do you to put the protractor on the I can't even draw it because this is such a weird angle. I'm drawing 2 dimensions. Yeah, trust me. There's no measurable angle at that point. All right, so 2-piece hub design. Let's see. We have the clamp rings. You could have wood or aluminum blades. I don't know why this is a subcategory of that, but wood or aluminum blades. Oh, I think because the clamps are different for wood clamp rings versus metal clamp rings. My memory is correct, but don't quote me on that one. We have the clamp rings. I don't know why I did it this way. Bolted. Got the bolted hub. Oh, okay, I know. Okay, so some of them have a type of a clamp ring that is used for wood or aluminum blades. And some of these hubs are bolted. So really, I think, in all honesty, let me go back to this. I just got to get my memory going here. Oh, this has clamp rings too. This style has clamp rings. Sometimes they don't have clamp rings like this, but the bolts go through the hub. It's machined into it. And sometimes those are clamp rings. So I'm just
Are the wood ones protected there?
Nope, not really. There's just wood shoved in there. So I'm going to erase this because I don't like where it is.
What's the torque on those?
I don't remember offhand. It's not a tremendous amount. You're just trying to keep them from rotating.
And if you loosen that clamp all the way, would that half of the blade come out?
No. As I would say clamp rings or a bolted hub. Bolted hub. And let me tell you why. I go back to this picture. Because even without these rings being tight, with this nut here, this nut is tightening up against this piece of the hub, which is touching the back piece, which is touching the back cone. So this is clamping the whole hub together. So sometimes you have to even loosen these up a little bit to get the blades to move. It's been a long time. In fact, kind of think that I always loosened it anyway. So I loosen this up because it releases the whole pressure on the hub. Or bolted hub. Let me see, blades. There we go, blades. So what kind of blades does it use? Blades. There we go. It may have wood, made wood blades for these. They made steel, mostly I see steel or aluminum. Actually, never seen an aluminum blade in this one. Has a root. The blade has a root with a shoulder. Shoulder machined into it. Into it to take the centrifugal loads of the blades, to take the centrifugal loads of the blade wanting to depart and run out and go away. I only see this style and I wrote in my notes, may fit all three types of crankshafts. I don't know, somebody wrote that and I just blindly copied it. I've never seen this type of hub on anything but a spline shaft. Just trying to think if I've ever seen anything other than that. Yeah, maybe. Now that I think about it, I can see how it would be made, and I think I might have. So I'll go with it. Installation may fit, may be found. Of course, it'd be different, slightly different styles for each one on all three types of cranks, which would be taper, splined, or flanged. But really, it's just the type of prop, the era, everything really matches more of a spline shaft. Okay, so the next slide I would have brought into the classroom, and I didn't think to bring one. A prop protractor, and I would explain to you all how to use a prop protractor. But honestly, the best way to figure out how to use a prop protractor is just to have one in your hands and mess with it a little bit, and have me show you once and then let you mess with it. So
How much are those?
I don't know. I wonder if you can buy one. I'm going to guess at least $1,000 if you could find one.
That's for that Snap-on brand, huh?
Snap-on doesn't make anything like
Yeah.
that.
Right. Well, how many?
There's a digital
$1,784.
Thank you. Right there. 1,780. That's a nice picture, though. I do like the picture. It's a beautiful picture, actually. And so what we have here is this bubble swings out. This is just this way for storage. It swings out so that you actually have it level in two different planes. And the idea of it, and you can just relax a bit, I'll show you, is you have to be able to zero this out even if this is crooked. And the reason why is I can't draw on here at the same time. Well, let me see. Hang on, something here. No, I didn't want that. I want picture I had, and I want this tool. I want to say yes. I'm just going to copy this. And we'll bring it over here. Put it here, new slide. Paste it. Hey, look at that. Okay. Slideshow from current slide. There we go. Okay. So what I've got going on here is you have to be able, if you think about how an aircraft sits, like even a Stearman or something like this, it doesn't sit level. It's sitting with the tail on the ground and a tall landing gear. So the crankshaft is kind of coming up at an angle like this as it sits on the ground. So here's the crankshaft. And I want to figure out this blade angle that's it's over, you know, I'll just make up a blade angle. Well, one blade's going this way and another blade's going that way simply because of the way the aircraft is sitting. So if I go back to here and here's a picture of it. So one is sitting this way and one is sitting that way. So what I have to be able to do is take and find a spot, and maybe I would do it from right here across these bolts, or in an ideal world, I'm going to set the protractor right here. And when I set it here, this has to be my 0 reference angle. And so that means at this point, the bubble should be saying it's perfectly level. Well, that's not perfectly level at all, but I need it to say perfectly level because that is my 0 reference. And so what happens is you loosen up one of these locks. It's not going to be it's this one here, but you loosen up the lock and you actually split it. Here's one of the locks, here's another one of the locks, and this adjusts it. So you actually unlock it from the frame, rotate it till this is perfectly level, then lock it in place. And now this bubble might be setting like this when this is like this. And so that becomes 0. And then you reference everything off of that. So now you're allowed to rotate this around. I just have to show you, and you have to trust me on that. But note right here that this is a vernier scale. So that's how accurate we're getting. And you know how to read a vernier scale, I hope. And that at some point, we may have this 20 close to here, but not quite lining up. And you better know how to read a vernier scale by now. So anyway, I will show you how to use that, but just understand that as a prop protractor and why we use a prop protractor, which is really just a bubble level that has a reading on it. That's all it really is. You can call it a protractor if you want, but you'll be pretty proficient of these things. All right, so but anyway, I had this whole thing about reading it, but I'm not going to go into there. Oh my goodness, I really went crazy. That page and that page and that page. But I'm going to give you some instructions here. I'll make this 0.5, even though it's 6, because you're going to need this, and you're going to need a little bit of help when you go to do this project in lab, especially who knows how long it's going to be until you get around to doing it. And so you're going to come back and reference this video or reference your notes, and there you go. So, so when I do this out in the field, so it's adjustments. Oh, I like to start with the reference point. So I mark blade to hub, blade to hub, alignment before any adjustments are made, before any adjustments are made. Adjusting these prop blades, especially if you have a prop protractor, it's not difficult, but it's also one of those things that if you're not paying attention, you can screw up horribly bad, hilariously bad. And I will catch at least 1 or 2 groups will do it, where in reality, you have one blade angle set. You're supposed to have both set the same, but you will have them so mixed matched that it's just comical to think what would happen if you actually started the aircraft. All right, so place the prop in a horizontal position. And to do that, I'm actually going to use the prop protractor in its actual, use it as a level, or I'll get a good known level, and I will put the prop horizontal, and I will place that that level across the top of the hub to make sure that it is in fact perfectly horizontal, because that's how you want to measure it. So, all right, loosen clamps and retaining nut, clamps and the retaining nut. And you always want to do the retaining nut because, as I said earlier, that actually clamps the hub together. So you want to loosen it all up. So once everything's loosened, then you can rotate the blades, rotate the blades, to the desired angle, oops, I want a W there. With blade paddles.
You have a picture of those?
Do you have one? I'll pull one up. I don't have a picture, but I'll get one. Huh. Nope. The interwebs is not going to cooperate on that one. I could draw one. It's not hard. They're easy to make. So if you can make them, I can draw them, right? So all you do is take like a 2x6 or laminate a bunch of plywood together. And so you make a paddle. So it's going to look just like an oar out of a boat. But now it doesn't. It looks like something different. All right, so you just start with a piece of wood that looks like that. But this has to be from here to here. That has to be, I don't know, a good 10 inches minimum to maybe a foot. And from here to here, sometimes that's usually, I don't know, 1 to 3 feet. And then you cut out this, just make a cutout like that. And so this is all cut out, and the propeller blade just slides in there, and then use the handle to go back and forth.
It looks like my mom's disciplinary tool.
That's it, and it would make a good disciplinary tool.
Wait, did you say the handle was 1 to 3 feet or inches?
Feet, all that, yeah, 1 to 3 feet.
Like that, Kevin, on my picture?
Wait, let me pull you up. I'm not even looking at you guys. I got stuff all over the place. That's it. Where'd you find that?
Way down on Google Images.
What'd you Google?
Ground adjustable prop blade paddles.
Wow.
Email it to you.
How much is that AccuMaster?
I've never seen anybody buy one. They just usually just make one. Well, how far down? When you get to the porn, go back up the other way. Yeah, send me a link. Okay, so rotate with the blade paddles. What else I got here? Rotate blades to desired angle blade paddles. Okay, then you check with the protractor. Check angle with protractor. Then you tighten the clamps. A, B, C. A, B, C, D. Oh, that was an E, that's why. E, F, tighten clamps. Recheck, because it will move at this point, which really stinks. Recheck blade angles. And then repeat as necessary.
I emailed that picture to you.
Okay. Repeat above steps until desired angle is reached. All right, tolerance. Tolerance is 0.1 degrees difference between blades. And 0.1 degree from manufacturer specs. So if I told you you had to be at 10 degrees, then you have to be within 1 degrees from what the manufacturer said, and then 0.01 across. Really, it's the manufacturer gives you a range. So the 0.01 is not so critical, but if it said like 8 to 10 degrees, well, you can be as much as 10.01 to 7.9, I guess. But between the two blades, then you have to be 0.1 difference. Otherwise, you're going to have vibration because one blade has got more bite than the other one, and you don't want that. So inspection and maintenance. I like this one. Same as any propeller, same as any other prop. Or I could say fixed pitch prop. So on an oral practical, inspect the prop. What are you going to inspect for? Security, cracks, chips, paint, proper installation. Always make sure you use anti-seize when you install it. I don't know, where'd I put that? Let's put it here. Use anti-seize. Because if you don't, boy, these things are a bugger to get off. And I'll put overhaul per manufacturer and manufacturer specs. I do not know what the overhaul period is on these things. Usually done with the engine or a prop strike. And that's all I've got to say about that. Because there's not much more to say about them. They're pretty easy to deal with. The interesting thing about these blades, though, is they are really an interesting shape. So you've got the back of the blade looks very normal, but the face of the blade is not, where it normally is. They're very concave, extreme concave. And so when you're doing it, usually when you use a prop protractor, you have a very flat face, and the protractor will sit well on the face. But these blades are actually so big that the prop protractor really doesn't even cover from this spot to this spot. It just about does it. So what you have to do when you have a very concave face like this, you use drill bits, and you can tape drill bits to it, like even an 1/8 inch will work. And just so you give a spot there, and then the protractor sits on those drill bits. There's my prop protractor. Just looks like something.
That's clever.
Yeah, so it's just a nice way to do it. All right, let's talk about automatic, automatic pitch change. Pitch change props. And the one we're going to talk about is that Kompers. Actually, here I spelled it right here. Koppers. Koppers. Thought there was an M in it. Oh well. Aromatic. This is the one I told you about that it's really bizarro in how it works. And I've attempted in past classes to explain it. And what ended up happening is like 3 people got it. And then the rest of the class was pretty much in their PeopleSoft with their finger on the drop class button. And so I'm going to try and make it very simple because that's what I should be doing. So I'll just make it as simple as I can. Let me see, make sure I'm going to make it simple here. Yes, we will. The Kompers aromatic. You know what? Before I get too far into this, I'm curious about something. Let's bring this over here. So you know what kind of weirdness I'm doing. Let's see. There we go. Aromatic.com. There we go. They're still in business.
They are the only manufacturer, or
No, that's who makes the Copper's aromatic prop is made by them. And so these are antique propellers. Right there, notice we're serving home built aircraft only. So these were actually certified props at one point. And let me just look at some of these cool pictures of them. But from what I can tell is they've lost their type certificate, if you will. So now they're just making them for home built. Like I said, it doesn't mean that they did something wrong. Sometimes that just has to do with the company was sold or something like that. But if you kind of notice it, it's not lined up. It's like the prop is sort of heading off this way and the hub is sort of setting off that way. And that is part of their design and how they work in this weird way. Oops, I should bring that back up. Make it go away. There we go. Can I go back? Just kind of look at what there is. Resources.
How did you adjust that?
Can you? No, you cannot. There's some limited adjustment to them. Let's see, flange shaft, blades only, hub, blades and hub. There we go. That's $7,000 and up for splined or for a flange shaft, which is what I would have thought of. They would go on because I saw these on lower horsepower type engines. So there you go. We'll put resources, disclaimer, service Bolton. Anyway, so there we go. They still have them. So there's the picture I have of one. And I don't know if I zoom in, we're just going to lose clarity. But as I was saying, you can kind of take a look at the angles that are created. And you can see that it's weird and that this one is kind of off at an angle this way. And this is off at an angle this way. And that one is over here this way. So this one and this one should be more parallel, but it's got little counterweights out here, counterweights out there. So counterweights, we have this offsetness. They're all kind of bizarro in the way they work. And I don't even, let me see where I'm at here. Here we go. So Coppers, we'll just go with this because I've got just a minute or two left. Aromatic prop. Automatically changes pitch in response to operational forces. In response to operational forces. And the idea is this places the best load on the engine, for optimal performance. So at high power, and low airspeed. So it's going to sense that. What do you think we're doing at high power and low airspeed?
Taking off.
We are in a climb. So in a climb, prop will go to a low angle. And then at high airspeed, and moderate power, we're in a cruise. Prop will be at a high blade angle. So So you got low pitch and high pitch. So down here at the low pitch, we're going to get higher RPM. We're going to get our first gear. And then once we get up and going at the high airspeed and moderate power, it's going to sense that and give us our third gear, if you will.
What a great
This
idea
seems like
for a prop.
this seems like an amazing idea. I was thinking the same thing, Harry. Like, why aren't there more manufacturers making these? This seems like this would be really good, especially on like smaller aircraft where, like 150s and things of the like. Like, why did they only have that one manufacturer? It seems like I would like, if I had the money, I would definitely put this on an airplane like mine.
Because constant speeds are better. But of course, you can't put a constant speed on an O200 or an Aranca like that picture I just had a minute ago. So, all right, I'll leave it right there and let you guys go get some food. And I'll be back.